Welcome to our science workshop. Today we're going to continue working on our module, Natural Resources in the Environment. Specifically on our first lesson, Energy from Non-Renewable Resources, trying to answer the essential question, how do we get energy from non-renewable resources? Today is Wednesday, May 27, 2020. Our lesson for today is titled Energy Changes. And our teaching point for today will be, I can analyze different energy types and explain how they transfer. In our last module, we had the opportunity to take a look at different types of energy. We discussed electrical energy, light energy, heat, sound, and so on. And we also took a look at how this can be transferred and actually how this could change from one form into another. So today we're going to be taking a look at how this might apply to other settings. Alright, if we try our first activity for today, we're going to find this passage that is titled Energy Changes, and it reads as follows. Energy is found in many forms. There is energy in light, heat, electricity, and in food. So as I mentioned before, we had, for example, light energy, thermal energy, which involves heat, also electricity, and food, that is usually found in chemical energy. When we eat, basically those molecules that contain the minerals and nutrients that food contains are broken down into our bloodstream, and that way we can benefit from the nutrients that they possess. We cannot make energy, but we can change it from one form to another. How is that? When we discuss about the law of conservation of energy, we learned that energy cannot be created nor destroyed, but it can be transformed from one form into another. That means that I can have, for example, electricity, and then that electricity I can transform it into thermal energy, or I can have light energy, and that one can be transformed into thermal energy as well, and so on. But what I want you to get is that we cannot create energy or we cannot destroy energy. It simply changes from one form into another. When we eat, we change the energy that was stored in food into the energy of movement, like when you run. We have two main types of energy, and below those two categories we have the different other subtypes. The first one is stored energy or potential energy. It is to say energy that we can use, that is able for us to use, but we're not using at the moment. And then we have kinetic energy or energy of movement, which is the energy of motion. This usually happens when the body is moving, or the molecules, particles, as you want to call it. Alright? So a car engine changes most of the chemical energy stored in gasoline into energy of motion. So right there we have an example of an energy change, where we have that chemical energy found in gasoline transformed into motion, in the sense that it provides the necessary energy to the car to start its motion. A microwave oven turns electrical energy into heat, and if we try a toaster or an iron, it will happen the same way. We have electrical energy being transformed into heat. If we keep on reading, sometimes energy is stored, right? Batteries store chemical energy. If we're gonna divide it into a circuit, electricity flows through the wires. Keep that in mind. That is something that we discussed in our past unit, and that we need to keep in mind. Keeping in mind that a circuit is a closed path, and usually that path is connected through wires. If we have an opening, the circuit is open, and then electricity can't flow. Wind-up toys store energy in a spring when you turn the crank, right? The stored energy or potential energy, these are two ways to call the same energy, in the spring changes into energy of motion when the toy is released. Basically, when we turn the crank a few times, what we're doing is building up that stored energy that when it is released, then it changes quickly to energy of motion, and the toy begin performing certain action. All right, talk about it. Discuss with the partner. What other energy changes have you experienced today? For example, this morning, I made a juice. So I actually put on a few fruits in a shaker, in a blender, and right there I saw how that electrical energy was transferred into mechanical energy that made the blade spin, and actually that way I could have my shake done. So basically I have energy, electrical energy being transformed into energy of motion. What other energy changes have you experienced today? Think about it. Alright, so now we continue with our second activity. Right there you will find another reading when we discuss about a day in the life of a nuclear engineer. If we go back, we have also spoken about electrical energy, actually electrical engineers, thermal engineers, but now it is time to talk about nuclear engineers. How would be a day in the life of a nuclear engineer? Alright, do you like making predictions? As a nuclear engineer, I monitor the supply of uranium. As we saw in our previous class, uranium is a non-renewable resource. Why is that? When Earth was created, it contained or it brought a specific amount of uranium. And as we learn about it, about the different uses that it has, we start digging and finding this mineral that is present in Earth. But guess what? As non-renewable resources, we need to wait for millions of years for this to be renewed. That means for us to have more. So that means that we can run out of uranium. And if we keep on reading, besides monitoring the supply of uranium and using computer models to predict how much electricity is produced. So basically what we do here is that we use uranium to produce electricity. And that electricity, you know that we usually use for factory and home purposes, right? That way we can conduct the different activities that we usually do that require electricity. So basically the use of uranium is using nuclear plants, power plants, that allow those elements to be broken down, and that way we can use the energy that they brought. I get to work as a nuclear engineer at a nuclear power plant that delivers electricity to many homes and businesses, as I mentioned before. We use uranium as fuel. There you are. Energy is stored in the center of the uranium particles. Uranium particles are split apart in the nuclear reactor to release stored energy. So basically, alright, we have uranium, but we need to process the uranium to split the atoms that are inside them, because when those atoms are split apart, the energy that holds, for example, protons and and electrons, is so strong that when they are apart, that energy that they contain is released in the form of heat. Alright, so we use a nuclear reactor to release stored energy. Probably you all have watched The Simpsons and you have seen nuclear plants right there, and you see this green bright element that is present in the intro they have. So basically it works sort of like that. The energy released in it is in the form of heat. Remember the steam engine in the locomotive? Coal was used as fuel to boil water, and power the engine to make the train move. This time, in the nuclear plant, uranium is used to heat water to turn turbines and produce electricity. So pay close attention to this last part. Coal was used as a fuel to boil water, right? And power the engine to make the train move. In the case of the nuclear plant, we have uranium used to heat water to turn turbines and produce electricity. So basically, coal was used to boil the water and make and produce energy to the train being able to move. And then we have the uranium heating the same water, but this time to produce electricity. Alright, so compare nuclear plant and a steam engine locomotive. Discuss with the partner. So basically, if you take a look at what we just discussed before in our last slide, you're going to see how these two, even though they're different, even though one uses coal and the one uses uranium, you see that at the end, they use these elements to produce another kind of element in the end. So take another look at that, and I'm really eager to hear your answer. All right, in our today's independent work in Inspired Science platform, you're going to try these 3. If you have any activity pending from Monday 25, I recommend that you try this as well. So you're going to begin with the one that says read about energy changes. You're going to try all the slides. Please make sure that you begin at number 1. Then you're going to continue with number 2, STEM connection, nuclear engineer, where we take a look at it in the life of a nuclear engineer. And then we're going to try the last one, where you're going to be reading and coming up with a fun activity that they have over there named fuel economy. So that was it for today, guys. I hope that you have enjoyed this lesson. If you have any questions, just let me know, and I will be glad to serve you. So I'll see you next time. Bye-bye.